Hi everybody, welcome back to Quantum Computing Weekly Recap. This week we have some interesting news about a stock you can buy. We have developments in silicon qubits, and we have cryptocurrency developments and more. So let's get right into it. First off, this week I want to talk about an ETF that's gaining popularity. This ETF is QTUM, and a lot of people are a little bit wary about investing in a single quantum stock, right? So what this ETF does is it gives you a bunch of different quantum relevant stocks. It's performed very well, and after Google's announcement of their Willow chip, there's been a lot of interest in QTUM. So if we do take a quick look at the holdings, though, we'll see that the first three are like exactly working with quantum, right? Rigetti, D-Wave, and IonQ. But the others are maybe quantum suppliers, quantum adjacent companies. So it gives you a bit of exposure with these different quantum stocks, but also if these companies do well, the idea is these adjacent companies will also do well. So interesting ETF to look at. Obviously, you won't be making as much in the quantum boom, but it's still a good way to diversify and invest in a lot of quantum stocks safely. For the next bit of news, we have advancements with silicon powered quantum computing. And this company, Equal One, has had a breakthrough in silicon computing, and they've reached quite impressive fidelities. So with single qubit gates, if you're applying an operation to a single qubit, like a single quantum bit, they have a fidelity of 99.4%. So they could have, hundreds of these operations and really only have a 4% chance of any error happening. So you could have 1,000 operations. So it's quite impressive fidelity, and their speeds are incredible. 84 nanoseconds for single qubit, and then for 2 qubit gates, right? So now you're operating on 2 different qubits at the same time. We have 98.4% fidelity, and even faster gate speed, which is pretty interesting. I don't know how that works, but very exciting stuff. I think it's especially interesting because with this method of silicon computing, they're able to use existing manufacturing techniques for classical computers, but they get to create a quantum computer from it. So you get to leverage existing silicon infrastructure. It's way cheaper to do it this way. You don't have to create entire new pipelines and entire new supply chains to create these quantum computers. You just get to start creating silicon qubits. So I'm looking forward to seeing what Equal One has to announce in the future, how they scale up their qubits, and how fidelity scales with that. They were using a 6 qubit array with silicon germanium, but we're at the point now where these companies have almost 100 or thousands of qubits, and I would imagine that the silicon qubit should be at about a few thousand for this to be useful. So we'll see how their fidelity scales and if they're able to keep up high entanglement across their chip. We have some interesting news coming out of crypto as well. A Solana dev was actually able to create a optional vault that you can use to make your funds more quantum safe. And this comes in lieu of research that is showing that Bitcoin is not quantum safe because the algorithms that Bitcoin uses to encrypt the chain, everybody's wallets, all of that, it's all vulnerable to Shor's algorithm. So when we have, millions of qubits in a couple decades, all of those Bitcoin funds are at risk. With Solana, the idea is your coin, your money is programmable, similar to Ethereum. So in this case, they use that programmable money to make a quantum resistant vault. The issue is, though, it's not really quantum safe. What they're doing is they're generating new keys for every transaction. So it's harder for a quantum computer to crack the key that they just used, but it's not impossible. And I think this is moving in the right step, but what they should do is use a proven quantum safe encryption method. And I think people are a little bit hesitant because they're new encryption methods. NIST recently, in the past year or so, approved different quantum safe protocols, but I don't think any cryptocurrency is using them yet. So when that happens, that will be a quantum safe encryption method. For now, it's quantum resistant. Moving into industry, IonQ and Oak Ridge National Lab unveiled their QITE algorithm for solving different problems. And this is an interesting algorithm because you can actually scale it well, and you can reduce the number of gates needed to solve these different optimization problems or combinatorial optimization problems. QITE's very special because if you compare it to something like QAOA, you have way shorter circuits, way less error, and you can actually find much more compelling results, more optimal results. So I think this is a great step forward. The theories we have and the ideas we have right now about how many qubits is it going to take to have a useful quantum computer, that is based on the algorithms that we currently are working with. But if we keep, pioneering new algorithms, and these different companies keep working on better and better methods for solving chemistry or solving optimization problems, we might even see useful quantum computers coming in the next couple years. I'm really hoping that's the case. This QITE algorithm is definitely the right step forward there. And Rigetti has some awesome news, launching an 84 qubit system. It has incredible fidelity. 99.5% for 2 qubit gates is really special, especially considering that they're working with superconducting qubits. So superconducting qubits are notoriously difficult to control. You have to be nearly 0 Kelvin, and any imperfection in the qubit is going to result in a lower fidelity. So this system has high enough fidelity where you can actually use a lot of the 84 qubits together. Congratulations to Rigetti. I'm looking forward to trying out their ankaa 3 system through their cloud services. And it'll probably be easier when, in the first quarter of 2025, it'll be coming to Amazon Bracket and Azure. So when that happens, a lot more people will be able to use Rigetti's new system, and 84 qubits is enough to do useful work with. So I'm looking forward to trying that out. We have some news coming out of Korea as well this week, where a quantum computing company, Norma, is using a cryogenic cooler from Maybell Quantum. And what's interesting about this is last week we looked at a story where a startup is creating different control electronics for quantum computers. So do quantum, and then they'll give you the classical control on top of it to do readout, to send that data to computers, whatever. I predicted that we would see more of this kind of one group focuses on quantum, the other group focuses on a different aspect of quantum. And just a week later, we see already that these two companies, Norma is dealing with quantum computing, and Maybell is going to be dealing with the cooling of that chip. I think we're going to see a lot more of these, partnerships to offload some of the difficulties in running quantum computers. This is definitely the right step forward, I think, for the whole industry. Sure, it makes supply chains a little bit more complicated. You're having to, have more dependencies on other companies, but I think it'll let people develop quantum computers a lot faster. So I'm looking forward to seeing, Norma and Maybell work together on this. And if it's a big success, which I hope it is, then I bet a lot more companies are going to try either creating custom components to solve one part of the quantum computing challenge, or other quantum companies offloading and outsourcing those challenges to other startups that are handling it. So I think this will drive the quantum computing space a lot faster. It won't be a single company working on all of the challenges. It'll be a bunch of different people from different companies all working to create really amazing quantum computers for everybody to use. So I love this story here. I think it's a great theme for 2025. And finally, now that we've entered the new year, IBM according to their roadmap, is set to release a quantum computer with over 4,000 qubits. That's going to be an incredible accomplishment from them. I'm really looking forward to using it. I think we can see news coming out of IBM where they're going to be using quantum error correction schemes, similar to what Google's Willow chip does. And with over 4,000 qubits, I mean, that's going to be hundreds of error correcting qubits that we can use. And once they have that, I think we're going to be able to actually have some useful superconducting qubits with high entanglement. And I say that because if you want to leverage a quantum computer, you have to entangle most of the qubits together to leverage that, high dimensional like space that you want to reach, and the Hilbert space, right? Like this 2 to the number of qubits, 2 to the power of the number of qubits space that you want to do math in and computations in. You have to entangle a lot of qubits to reach that point. And if you're using a superconducting qubit, that's like historically been pretty difficult to do. You get a lot of speed, you don't get a lot of entanglement. Maybe with over 4,000 qubits, if they can reach that inflection point in error correction where the more error correcting qubits you add, the less error you see. With 4,000 qubits and hundreds of error correcting qubits, you'll be able to do high entanglement, I think, getting useful results. 2025 might be like the year of useful quantum computing. Probably not, but maybe 2026 then. So I'm looking forward to this year. We're going to have a lot of very exciting advancements announced. Thank you so much for listening to this week's Quantum Computing Weekly Recap. If you liked the video, let me know, and hit that like button, hit that subscribe. I'll be posting every Saturday. If you didn't like the video, let me know, hit the down vote, and let me know what I can improve on next week. If you have any questions, please let me know. I'll be sure to answer them. Thanks so much for listening, you guys. I'll see you next week.